to the course on basics of computing, and this session is about insertion sort. So insertion sort is appropriate for small inputs, and the concept behind this insertion sort is the entire array will be considered as two sublists. One is the sorted sublist, the other one is unsorted sublist. What we are actually going to do is, from the unsorted sublist, we will take elements one by one and we will insert that element into a sorted sublist in appropriate position. On each pass, the first element from the unsorted list will be taken and we will find the appropriate path for that element in the unsorted list and it will be inserted. So, an array of n elements will take n minus 1 passes to sort the elements. We will just see the algorithm with a sample input. So this is the array which we have taken for execution. Let us consider the array name as A. So the size of the array is 6, that is why the subscript started from A of 0 and end up with A of 5. The elements of the array is actually unsorted fashion: 55, 22, 44, 66, 11 and 33. This is what the original list which we are going to receive from the user, which we have to sort in ascending order. Those smaller elements supposed to be in the first position and the largest element must be in the last position. That is what the objective. So as I told you in the previous slide, that is, the entire array is going to be considered two sub-arrays. We are going to split the array into two sublists, sorted sublist and unsorted sublist. Here this specifies the sorted sublist. Initially, for sorted sublist, we are going to consider only the element at 0th position. That is, A of 0 is alone now sorted. So when there is only one variable, obviously it is going to be a sorted one. We don't mind about its position because there is only one element which is definitely in its position. And then the remaining parts which is mentioned here, that is unsorted sublist, which is from A of 1 to A of 5, which is considered as unsorted sublist. Then we're going to have one more variable called temp. So using this temp, we are going to store temporary variables in this during swapping operation. So what is the logic? From the unsorted sublist, we have to take the first element and then we have to find appropriate position for this element in a sorted sublist. That is what the algorithm. So first we have taken the first element that has to be stored in temporary variable, so which has been stored now. Though we have copied it, we can consider this A of 1 position as an empty space. That means what? It is eligible for us to store some other variable value in it, because the backup of A of 1 is available in temp. Then we have to compare our temp value and the remaining sorted sublist elements. As this is the very first pass, we have only one element in the left hand side, which is A of 0. So we are comparing our A of 0 and temp. If A of 0 is greater, then as per our condition, A of 0 is 55 and our temp value is 22. So this condition is true. So we have to move the A of 0 to 1 position right side. That means we are moving the A of 0 to A of 1. So 55 is now moved to the position A of 1. And it is not that we are actually swapping. First 55 will be moved and 22 will be stored in A of 0. Not like that. We have to move this and still the A of 0 is a question mark. And then we have to check, is there any more elements in the left hand side? Left hand side means it is sorted sublist. Is there any more element? No, because this is the first pass. We have only one element. That element was a of 0, which we had already checked, which has been moved to a of 1. So there is no more element in the left hand side. So if there is no more element in the left hand side, what we have to do? Then we have to copy the temp variable into a of 0. So now the array is 22, 55, 44, 66, 11 and 33. That means the first two elements a of 0 and a of 1, they both are in its appropriate position. Now, so that we can call this green line, that is a sorted sublist, and this one as unsorted sublist. So once you are completing your first pass, you are getting two elements in its position. Here comes the array's second pass. In the second pass, the input is the two sorted elements and the remaining unsorted elements. Again, we have to deal with the temp. So in that temp, what we have to do? The a of 2, from the unsorted element to the first element. So this is the first element in the unsorted array. So that has to be taken, and which has to be stored in temp. So as we have the backup of this a of 2, this can be considered as an empty position. If required, we can move any element from the left hand side. Then as usual, we have to compare a of 1 with our temp. Why it is a of 1? Because from the left hand side, in the left hand side sublist, that was your first element, and then we are comparing a of 1 with the temp, and if a of 1 is greater than temp, then we have to move that a of 1 to one step right. So your condition is a of 1 is 55 and your temporary variable is 44. So the a of 1 element is greater than the temporary element. So we have to move a of 1 to one step right. So once we have moved, we will be filling that a of 2 in 55th position, and still a of 1 is a question mark because we haven't completed the entire sublist in the sorted array. Then, is there any more element in the left hand side? We have processed only a of 1. We have still a of 0, which is to be processed yet. So we have to compare a of 0 and temp. So what is your a of 0, which is 22, and your temporary variable is 44. So here your variable is actually greater, the temporary variable is greater than the a of 0. So we no need to go for right shift, we have to place the temp variable in a of 1. So that is what we do. As a of 0 is not greater, we are copying the temp value to a of 1. So upon completion of this path, you are getting 3 elements in the sorted sublist. In the unsorted sublist, 3 elements are there. So how many passes we have completed? Pass 1, and this is pass 2. How many passes actually we need to do? N minus 1 passes. So we have to go for 3 more passes to complete all the 6 elements in its position. So this is pass 3 for you. In the pass 3, the input is first 3 are already in sorted order. The next 3 elements are in unsorted order. Then we have to introduce again the temporary variable, and in the temporary variable, the first element of the sorted array has to be removed and it has to be placed in the temporary variable, and then this temporary variable must be compared with all the elements of unsorted sublist. So starting from a of 2, which has to be moved to a of 0 till move towards a of 0. So we are comparing whether a of 2 is greater than temp. So your temp is 66, your a of 2 is 55. So it is actually your temp is greater. So you no need to do any change. Simply you have to go and check for any more elements available in the left hand side. Is there any more elements in the left hand side? Yes, we have processed only A of 2, we have A of 1 and A of 0. Then A of 1 and temp must be compared. So A of 1 is 44, temp is 66. Still temp is only greater, so no need of right shift, which is again leading you towards going for next iteration. Then is there any more elements? Yes, we have one element which is A of 0, which is to be compared with your temp variable. So if A of 0 is greater than temp, again it is not. So what we have to do? Is there any more element beyond that A of 0? Definitely it is not. So we are copying the temp to A of 3. So once it is copied, your array will be sorted for the first 4 elements. 22, 44, 55, and this time we have stored 66. Now first 4 elements are sorted, the remaining 2 elements supposed to be completed. So now we have completed up to pass 3. So this is for your pass 4. The input for pass 4 is the first 4 sorted elements and the remaining is unsorted element. We starting from A of 4. As usual, we will introduce the temporary variable. We will take the element from A of 4 and we will replace it in the temporary variable, and the temp variable must be compared with each element from sorted sublist and from the sorted sublist higher position to the least position. Right now the highest element in the sorted sublist, the highest position in the sorted sublist is A of 3, which has to be reached till A of 0. We are comparing A of 3 with the temp. A of 3 is 66, your temp is 11. Yes, it is greater. If it is greater, we have to shift this one step towards right. So once you are shifting, it will become like this. Still, this is a question mark because I cannot put directly that 11. We have to find the appropriate for this 11. How to find that? We have to traverse in the left hand side of the array, which is what your sorted sublist, and then we will find the appropriate place. As of now, A of 3 is a question mark. Then as usual, we will be checking, is there any more elements in the left hand side? Yes, it is there. So what we have to do, in the next element, A of 2 will be compared with 11. Again, this A of 2 is greater than your temp value. So you are moving this A of 2 to one step right. So once you are moving that, it will be like this. In the position of A of 2, this is a question mark because we can't fill your 11 here also because we haven't completed the sorted sublist yet. As again, we are checking for any more elements in the left hand side. Yes, we still have elements. We have to check for A of 1 with the temp. A of 1 is 44, your temp is 11. You are comparing your A of 1 with the temp. 44 is greater. As it is greater, we have to move that 44 to one step right. When you are moving, you will be getting like this. So A of 2 will be stored as 44. Your A of 1 is still, it is a question mark. Then we have to check, is there any more elements in the array left? Yes, it is. There is one more element left, which is what your A of 0. Then you have to compare A of 0 and temp. So your A of 0 is 22, temp is 11, and this time also array element is greater, your temp is lesser. So once again we have to go for shifting one step right. So once we are shifting, we will get 22 in A of 1's position and A of 0 is still a question mark. Then we have to check, is there any more elements in the left hand side. As we have already checked the A of 0, there is no more element in the sorted sublist to compare. So the condition will be false. What we have to do? We are storing the temp value to A of 0. So 11 will be stored in the position of A of 0. Then this is pass 5, that is n minus 1, the last pass. So the input for the last pass is up to 5 elements it is sorted. Then remaining only one element which may be in the position or which may not be in the position. Only when we complete this part we will be coming to know what is the appropriate position for 33. Then again we have the temporary variable. So the temporary variable must hold the A of 5. Sort in the unsorted array, first element to be stored in the temporary variable, and then we have to start comparing it. So we are taking the value from A of 5 and we are storing it in the temporary variable, and then we have to start comparing it with each element in the sorted sublist. So first comparison is A of 4 and temp. A of 4 is 66, your temp value is 33. So if the array element is greater, then what we have to do? We have to move that element to one step right. So when we do so, you will be getting like this. The element position, the previous position of the moved element is now is a question mark. We should not put that 33 over here because we haven't found the appropriate place for 33. Then we have to check, is there any more element in the left hand side? We have processed only one element. We still have the remaining elements until we reach 0. It is true. So A of 3 has to be compared with temp. So A of 3 is 55, your temporary variable is 33. So again A of 3 is greater than the temporary variable. When it is greater, you have to move this A of 3 to one step right. So when we do so, you will be getting this as a result. So A of 3 is a question mark because we had moved that 55 to A of 4 position, and then we have to check, is there any more elements in the left hand side? Yes, we have 3 more elements in the left hand side. Yes, it is there. So we have to compare A of 2 and temp. So A of 2 is 44, your temp is 33. Once again this will fall under the condition of greater is true. So we have to move this 44 to A of 3 by leaving the A of 2 as question mark. So 44 has been moved and A of 2 is a question mark. Then we have to check for any more elements in the left hand side. Yes, we have, because we still have one more element, A of 1. So A of 1 has to be compared with the temp. A of 1 is 22 and your element is 33. When you compare these two, it will be giving you false as a result. That means what? Your element is found for the appropriate position. It is beyond 22, we can't place that 33, right? So when it gives the false condition, we have to copy the temp to A of 2. So finally you will be arriving with this. We should not proceed further because in the right hand side, in the unsorted list, we have covered until the length n minus 1. In the sorted sublist, we have processed till A of 0. So this is the termination point for your program. So once you are completing this, we will be getting the final sorted array. So the concept behind insertion sort is the entire array will be divided into two parts. One is the sorted sublist, another one is unsorted sublist. From the unsorted sublist, each element will be picked and we will find an appropriate position in the sorted sublist for the unsorted element and we will insert it. So when we are creating the loop, we need two variables. One variable is for traversing with unsorted sublist. Another variable is for traversing in the sorted sublist. So when we traverse like that, this unsorted sublist will be starting from A of 1. The I value will be 1, whereas the sorted sublist will be having J value as 0 0 because this is A of 0, very first position only we are comparing that, we are considering that as sorted list. Then the remaining all the elements are considered as unsorted sublist. How the traversing is actually happening in the unsorted list, the I value is incremented every time. So first time it will be I is 1, second time I will be 2, third time I will be 3, like that it will be going. Whereas in once the first element is taken in the unsorted sublist, how we have to compare in the sorted sublist from the higher order to lower order until we reach 0. Just we will take this part as an example. If I am here, if we are taking this 66 element for comparison, then your I value is starting from 4 and it has to go till less than n, that means up to 5. Here the j value is I minus 1, that is I is 3, 4, I minus 1 is 3, from 3 till it reaches 0. So this is how we have to create our loops for completing the task using insertion sort.